Okay, I just wanted to talk some more about what we need to look at for exponential functions in context. So identifying like what piece of the information, how it is represented in the equation. So when I ask you to identify parts of the equation in words, you can do that, like what was done in the review. So for first, we're just going to look at some questions and write the equations. So we have John who opens up a savings account that has an interest rate of 0.95% annually. He deposits $1,500 in the bank to start. What will he have in the account after 10 years? So this all goes, again, just like what we talked about before, we're always starting with that y equals and then that ab to the x power. That's our exponential function. And then we need to figure out what each piece is in the context of the problem. So when they're asking us to find the amount, what will the account have in 10 years, that's my output. I don't know what the y is. I don't know how much is in the account. But I do know the initial amount, what we started off with, was the 1,500. So that's the number that doesn't have the exponent. And then I know the rate, since it's a savings account, it better be going up. So it's going to be a 1 plus the rate. 0.95%, well, off to the side, I'm going to change that. 0.95% needs to be changed to a decimal. So that is 0.0095. So we had to move the decimal place 2 places to the left to change it from a percent to a decimal. So now I can go back over here and plug that in to my R value and then raised to the 10th power because this is 10 years later. So maybe that's not as difficult, but it seemed like in the question that I gave, it was difficult to identify what each piece stood for in the problem. So what does this represent? 10 years after opening the account will have, and then the output, the balance, as my answer. So now that we put this all in, we would just put this into our calculator to get the amount. And remember, when we're talking about money, we always go to the nearest penny because money can go up to 100th or a penny. So that's how if they don't give you rounding rules, you're just rounding to the nearest penny. Unless they say something like round to the nearest dollar, then we're just going to go to the nearest penny. So when I put this in my calculator, I get 1,648, and then we have this long decimal. I usually start by writing it out just because I don't want to have an error. If I have an error when I round, at least I'll know it was from rounding and not from that you didn't know how to do the question. So that's why I usually have my friends write it out all the way so that I can see that if you do make a mistake in this last step, it was just a rounding error and not that you had the wrong answer in your calculator. So 1,648, rounding to the nearest penny, the 4 in the hundredths place, and I look at the 8, that tells me to round up. So my answer would be $1,648.75. So again, what does this mean in the context of the question? It means that in 10 years after opening the account, John will have $1,648.75 in the account. Okay, so identifying exactly what the inputs and the outputs are. So now that I've done one where we wrote the equation, we're going to do this where they're actually asking us to identify initial population, how much it's decreasing, and how many polar bears there will be in 5 years. So the question says the population of polar bears in the world is decreasing and can be modeled by this function. T is the amount of years. Using the function, answer the following. What is the initial population? Well, initial population, remember, that's like talking about our A value. I don't know in my equation the A value because we're using that y equals AB to the x power. So if we look at my function here, we have P of t, that's the same as y equals. This is the number without the exponent. That's my A value, A, and then the 0.91 is my B. T is used instead of x. So my initial population is 18,600 polar bears. Okay, so we need to make sure that you're looking at the equation to determine that. The next part says, what percent is the population decreasing per year? So what is it decreasing? Well, it's 0.91%. So it's 91% of the population. But that's not how much it's losing. That's how much it is. It's 91%. So how far away is that? That is, you could take it, remember we talked about you could subtract it from 100. So you could say I have 100%, and I'm going to subtract that 91% to figure out how far away it is from 100. And then we get that answer of 9%. So that tells me that the population is decreasing 9% per year, because it's actually 91% of the population, but that's a decrease of how much? How far away from 100 are we? And the last one says, how many polar bears will there be in 5 years? So now we would just plug in the 5 in place of my t. So I rewrote everything exactly the way that it was in the problem, but I just replaced the t with the 5 because it's 5 years after. So 0.91 and then raised to the 5th power all in my calculator. And we end up with, now this is, remember we talked about these are real life situations. So first I'm going to start by writing down what my calculator told me, which was 11,606, but I have a decimal. So I'm going to first write it so that I know, okay, well this is what my calculator told me was the answer. However, we can't create a polar bear, so my answer would be 11,606 polar bears, because maybe that means that 0.99, maybe that means that one of them is going to have a cub or something like that, but it's not there yet. I can't create it. If it's not actually in my number part, we're just going to ignore it because it's not actually in the population just yet. Okay, so I just want to talk again about how these represent the polar bears. Now, there are 11,606 polar bears. That was the P of T. This is T years, so in this example, it's 5 years later. Now, the question in the Delta Math talked about the college and how much college cost, and you had to determine what the C of 4 represented. So it'd be similar to finding like this P of 5. The only difference is for the question that in the Delta Math assignment, they gave you a starting value. So let's pretend for a second this polar bear question, let's say that they said this started in 2000, for example. Well, then what would this down here, this 5 years, so P of 5, what would the P of 5 represent? Well, the 5 would go in place of the T, but that would be 5 years later. So that would tell me that in 2005, there would be 11,606 polar bears. Now, in the question that was on the Delta Math, they were asking you what the C of 4 represents. Remember what that represents by reading back into the question and determining what your output is. When you plug in the number of years, what comes out? That's the question in the Delta Math. So hopefully that helps answer that question. And we will have, and I'll recheck those again, but you need to go back and I give you a second shot at redoing that question. And in addition to that, I'm going to add some questions on here that talk about reading these in context. I didn't answer this last question, that was on purpose. I just wanted to talk about what the representations are. I need you to know what the inputs and outputs stand for, and more questions will follow this to make sure that that makes more sense now. All right, have a great day.